Sorry about that. Okay, so this lesson is quadratic functions and equations, and you'll be able to graph quadratic functions and solve them as well. So what is a quadratic function? So quadratic functions are the functions, you've seen them before. It's where the the lead where the degree of the one variable polynomial is 2. Okay, the degree is 2. So the highest exponent is 2. So x squared something something. And when we graph these quadratic functions, we end up with parabolas. And parabolas are those U-shaped graphs like you see there on the board, right? It can be up like that, or it could be down like this. Okay, and we'll talk about how to get those later. Yeah, let's put that on the notes. Parabolas. There you go. Okay, so let's graph each equation by making a table of values. So this is the basic way to graph any function. So if there's going to be some quick ways to graph different functions. Okay, if you forget any of those during like a test or a placement test or whatever, the best thing to do is to make a table and then graph it, because you can graph any function with a table. So yeah, let's do that. So let's make a table. You can make it horizontal, vertical, whatever. So here we're gonna have our table like that. X, here's the Y's, and and yeah. So you're just gonna choose some values. Okay. And I'll show you how to choose these values later. So right now we're just gonna, because this is our first time, we're just gonna choose like random values. So yeah, we're just gonna choose random values here. All right. So the book for that example they started with 0. It's okay. Let's choose other values. Let's choose, you technically only need 5 numbers. However, when you're not too sure, you could put more. Okay. I'm going to do -2, -1, 0, 1, 2, 3, 4. Let's do like that. And then what we want to do is we want to plug in those values. Those are the x values. We're going to input them into our function. So we're going to find out what f of -2 is. So we plug in -2 for each of these. And I'm not going to show it for all of them. Just for this one, maybe another one, just so you can see what to do. So just plug those in like regular, right? And then, yeah, you get 4 minus 10 plus 6. And there you end up getting 0. Ooh. Oh, ho, ho. Look at that. So we get 0 there. And then, yeah, let's do f of -1. You get -1 squared plus 5 times -1 plus 6. -1 squared is 1 minus 5 plus 6. Going to give us 0. I'm just kidding, 2. 2. And yeah, the f of 0 is actually really easy. Whenever you plug in 0, you just get your constant. And this is actually going to be a special number. So we just get 6 here. All right. And the rest, if you want, you can uh, plug it into Desmos. Now I'm noticing something. Notice how it keeps going up, right? We actually wanted to go down and then up. So we're gonna we're gonna change our plan here. We're gonna make this choose some more that are to the left of -2. Let's use -5, -4, -3. All right, so we're gonna do f of -5. It's gonna give us -5 squared plus 5 times -5 plus 6. Okay, I said that we were just gonna do a couple of these. Let's do the rest on Desmos. Yeah, 25 minus 25 plus 6. Hey, look at that. Ta-da! It matches. Okay, I think we got it. Okay, so let's find f of -4 and f of -3. So we're just going to plug those into Desmos. So go to Desmos, and then here, just write down -4 squared plus 5 times -4 plus 6, and plug that into Desmos. Let's see what we get. So make sure to put parentheses for these whenever you square a negative. Plus 5 times -4 plus 6. All right, we end up with 2. Hey, hey, hey. And I'm going to guess this one's going to be 0. All right, so with Desmos, it's nice because you could just erase the x's. So instead of -4, I'm going to replace it with a -3. And instead of -4, just replace it with a -3 again, and we get 0. Hey, how did I know? Okay, the reason why is because parabolas are symmetric. Yeah, so as soon as you see two that are matching, that means there's going to be, the rest are going to line up as well. Okay, so you just graph those. We have -5 and 6, -5 comma -5 comma 6, -4 comma 2, -3 comma 0, -2 comma 0, -1 comma 2, and 0 comma 6. All right. So here we don't actually get our vertex, and we'll talk about what a vertex is later. We don't have a vertex, so we're just going to estimate it. So we just graph it. Oops, it's horrible. Right. So it's going to be in between -3 and -2. It's actually going to be -2.5. Okay. But we'll find out how we got that later. Okay. And that's it. So again, we noticed that here the numbers just kept going up. We don't want that. We want it to go down and then up. Okay. So if you notice that it keeps going up, then use some numbers to the left of those. Okay. And we'll find a shorter way to do that later. Let me put that on the notes. Oh, I mean, we're going to find a way to determine which values to plug in. Okay, as soon as we find the vertex. I don't think it's going to be in this chapter, this section. All right, and you want to do the same thing with number 2. Wait, should I try in the others? Yeah, let's do some other ones. Which one looks nice? Let's do 6. Yeah, why not? The negatives. All right, looks cool. All right, so here's our XY table. All right, need at least 5. So I'm going to do -2, -1, 0, 1, 2, 3, 4, etc., etc. Okay, so let's plug in. Now be careful of that negative for the lead coefficient. Okay, so we have f of -2 is -2 squared minus 3 times -2 minus 1. And -2 squared is going to give us 4. And -3 times -2. Negative times a negative is a positive. So it's about 6 minus 1. We get 1. And then f of -1. Oh, sorry. 1. F of -1, -1 squared minus 3 times -1 minus 1 equals negative, and then -1 squared is 1. We get plus 3 minus 1 is, so 3 minus 2 is 1. Hey, look at that. Lining up already. There's our symmetry. So notice how those are right next to each other. Okay. Those are the same y values and they're right next to each other. So um, that means our vertex is actually in between -2 and 1 somewhere. Where? We'll find out. Okay. And then here, f of 0, -0 squared minus 3 times 0 minus 1. You get -0 when there's no -0. So -3 times 0 is 0 minus 1. Why didn't I just put -1 before? I don't know. -1. Hey, look at that. It's going down this time. Oh, okay. Sorry. Before I said if it's just going up, then you want to go to the left. If it keeps going down, okay, and it doesn't go back up, then you want to choose some numbers to the left as well. Okay, and you'll see why soon. So f of 1, -1 squared minus 3 times 1 minus 1. Let's just use Desmos, even though that one isn't too bad. The -1 squared minus 3 times 1 minus 6. Sorry, minus 1 is -5. Yeah, and then just keep plugging those other ones. F of 2. And this is the last one we'll do. You don't need the rest. So replace all those ones with a 2, and you get -11. Can't even put it on the graph. Okay. So here we have -2 common 1 and -1 comma 1. And we have 0 comma -1 and 1 comma -5. and 2 comma 11's all the way down here. So it doesn't even make it on the graph. So one thing that we're going to talk about is that parabolas are symmetrical. Okay, so there's this line in the middle. You can probably imagine it. This is going to be called the axis of symmetry. Axis, that line in the middle, and symmetry is where, so the line where the shape is symmetrical. Okay, and remember from geometry, symmetry means it's the same distance. Okay, half, half. There you go. So this one is 1.5 spaces. So you're going to go 1/2 and 1. 1.5 spaces over here. Ta-da! This one is 1, 2.5. So 0.5, 1.5, 2.5. And same thing over here. Yeah. 1, 2, 3.5, 0.5, 1.5, 2.5, 3.5. And that's it. So connect the dots there, the vertexes above, and that's it. That's our wonderful parabola. Notice how that one goes down because it's a negative. Remember, and we'll talk about this later, when that lead coefficient is positive, it's smiling, it's happy. But then when the lead coefficient is negative, it's sad, okay? It's frowning. That's the easiest way. And A is the lead coefficient, if you're wondering what the A is. Okay, so the coefficient of x squared. All right, so we're actually going to talk about that pretty soon. So here we go. This on the notes. All right. Now here it says a batter hits a baseball with an initial speed of 80 feet per second if the initial height of the ball is 3.5. Okay, that's where this constant comes in. Feet above the ground, the function 80t, so the 80t minus 16t squared plus 3.5 models the ball's height above the ground in feet as a function of time in seconds. Graph the function using a table of values. So notice that it's not in order, okay? It's not in standard form, okay? Because the square should always go in front. The degree should be in descending order. So the biggest degree and then the smaller, smaller, smaller. So this should actually be negative 16 t squared plus 80t plus 3.5. And that constant is always last. Okay. So biggest degree first, and then keeps going down. 1, 0. Okay, so put it in order. And then notice that our lead coefficient now is negative. Because our lead coefficient is negative, we know it's going to be going down, which is what the projection of a baseball does. It goes up, and then because of gravity, it goes down. Okay, so yeah, you can graph it using the table of values. So you want to do the same thing. Just make a table and use those values there. Okay, so nothing different. I just wanted to talk to you about that quickly. With the same thing except different numbers to plug in. Okay, now we're going to talk about axis of symmetry. So it's a line that divides the parabola into two halves that are reflections of each other. Okay, notice that because the parabola is symmetric about the axis of symmetry, points B and C are 4 units from the coordinate of a vertex, and they have the same y-coordinate. So same y-coordinates have are the same distance to the axis of symmetry, like we talked about before, with the 1.5, 0.5, and then 1 in the previous example. Okay, and then the vertex is that turning point. So the vertex here is our turning point. Okay, that's where, because here we're decreasing. So we always go, this is confusing because of the arrows. Okay, it looks like you're going left. Okay, but here you want to imagine it going down, going to the right. So start here, and as you go to the right, notice that it goes down and then turns here at the vertex and goes up. Ta-da! So that is the vertex, the turning point. Okay. And some placement tests, they do ask you about describing where it's increasing and decreasing, and we'll actually talk about that later on. Okay, in a different chapter, I believe it's chapter 1. All right. And then here, uh, we do have a formula to find the axis of symmetry, which is really important, but we don't have time because it's 12:20. So I will discuss this in the next video. And yeah, so our axis of symmetry though, if you can't wait, is x equals negative b divided by 2a. X equals negative b divided by 2a. All right, and we will look at that tomorrow.